All right, Unit 2, Linear Programming. This is a throwback to Algebra 2. Actually, we did this the last unit of Algebra 2. So hopefully it looks familiar. So we're going to be graphing, okay, graphing inequalities. Now remember, the only difference with graphing inequalities is that you're graphing lines, solid or dashed, but these are usually going to be solid. You're graphing lines, and then you're shading one side of the line or the other, all right? These are the most common constraints we have in the limits or constraints. We'll use that term here in the next chapter or section. But basically, this is saying in the 4 quadrants, we want greater than x, greater than y of 0, which basically means we just want this first quadrant. Why is that? Because these are always going to be real world scenarios. And in the real world scenario, we can't go like backwards in time or make negative products in a factory. Everything's going to be positive numbers in the real world. So whenever you see this, you basically end up with this, the first quadrant, with 0, 0 down here. Also, this is the most commonly, when we get to the next section, most commonly forgotten constraints to write down when we're going backwards from a word problem and trying to figure out what these are. Right now, I'm giving you the constraints in this first section. You don't know what that means, unless you remember from Algebra 2. But constraints basically are the lines that are based on a word problem that set up how the graph's going to look. So in the real world, this might be like I'm charging $3 a bag for this and $6 a bag for this item, and I want to make $30, less than or equal to $30, or something like that. That's where it'll tie into real world problems. So let's go ahead and graph these. Now, when you're graphing these, you have 2 choices. You can do the old solve for y, okay, which means you move this over. So you'd have 3y is greater than or equal to negative 6x plus 24. And then you divide by 3, and you get y is greater than or equal to negative 2x plus 12. This is your y-intercept of positive 12, and this is your slope of down 2, right 1. So you have that ability to do that. So you can start at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And go down 2, right 1, down 2, right 1. And keep repeating this pattern until you get here at 1, 2, 3, 4, 5, 6, 0. Okay? And you connect the dots and use a solid line because it was or equal to. Or you can do the cover-up method. If this number and this number are a factor of this number, the cover-up method is awesome. Because you just do this, cover that up, and you solve for y. So 24 divided by 3 is 8. So that means y is 8. So we plugged in a 0 for x and got 8 for y. I'm sorry. I just realized before I made a mistake. Hopefully some of you caught it. I divided by 2 instead of 3. So that should have been 8. So I need to start over, which happens. So I'm starting at 8 now. 1, 2, 3, 4, 5, 6, 7, 8. It's still a down 2, right 1 slope. It's just going to end up instead here at 4, 0. Now, the cover-up method, I move this over here and cover up my y and divide 24 by 6, and then I get that 4, not 6. So my y is 0, and my x is 4. So 4, 0. So I could have just plotted that and just plotted that and used a straight edge to connect the two. I'm using the other method because I don't have a straight edge on this, so I'm trying to be as exact as possible. Now we have to test. And as long as it doesn't go through the center, the best point to use is 0, 0. So I'm going to go back to my original problem. I could go over to y equals 1, but this is easier because 0 makes everything on this side disappear. And I get 0 is greater than or equal to 24. True or false? Well, 0 is not bigger than any positive number, so that's false. which means I don't want to shade on this side of the line. I want to shade on this side of the line. And you don't have to shade in like we're coloring a coloring book. That makes it really difficult to see where we're going later. So, moving on. As I've said in class, also you can use colored pencils, which kind of helps. So I'm going to do that here. I'm just going to do the cover-up method on this one. So if I divide 30 by 6, y is 5. So that's 0, 5. If I move that over here, I get 10. X is 10. So that's 10, 0. So 0, 5, and 10, 0. 5, 6, 7, 8, 9, 10. Okay. And that is a slope of negative 1/2. So I'm going to go down 1, right 2. Oh, there's a point of intersection. That's important. And I'm going to keep going down 1, right 2 until I get here. This point of intersection is very important. Now I go back up to the original one. I'm going to plug in 0 here, get less than 30. That's a true statement, which means I'm going to shade underneath here. And I'm almost done, except instead of having, no, never mind. In this one I have 0, 0, so there's no extra horizontal or vertical lines. So I am ready to find my region, which is where I have green and black. So that's this little triangle right here, like so. That's my region. That's where everything overlaps. And now I need to find the corner points. That, and that. So again, we said that was 5, 6, 7, 8, 9, 10, 0, 4, 0. And this point up here is 1, 2, 1, 2, 3, 4, 2, 4. Those are the corner points that form the overlapping region. All right. Now, on this one, it's a little bit different. We do have not x is greater than 0, y is greater than 0. So we're going to have a horizontal line at 10 and a vertical line at 20. All right. We're also not going to have enough space on this graph, so we're going to count by a different number, probably 2's. With the cover-up method here, there's a problem. 5 does go into 200, but 3 does not evenly. So in this case, the cover method is not the best. I'm going to do y equals mx plus b. So 5y greater than or equal to negative 3x plus 200. Divide by 5, greater than or equal to negative 3/5 x plus 40. Okay, so I need to be able to fit 40 on the graph. So let's see if I can count by 2's and get there. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Well, there's 40 right there. Okay. Now my slope again was negative 3/5. That's also a problem because I'm counting by zeros. I'm sorry, counting by 2's. So that makes it challenging, right? So what would my x be? If I cover my y, we can approximate, but it's going to be imperfect on this one because the numbers don't work out nicely. So I'm going to do a little math magic here. This is also negative 6/10, and those are both even numbers. So now I can count down 6, right 10. I just have to remind myself every time that each line is 2. Okay, so down 6 is 2, 4, 6, and right 10 is 2, 4, 6, 8, 10. And down, so what I'm realizing is this is going to go off the graph, but we'll work with it. So down 6, 2, 4, 6, right 2, 4, 6, 8, 10, 2, 4, 6, 2, 4, 6, 2, 4, 6, 8, 10, 2, 4, 6, 2, 4, 6, 8, 10, and you can tell this is going to go off the grid. it's going to continue down here and hit, and actually it's going to hit at 66.6 repeating. All right, and this only goes to 40. So that's fine. You'll see why in a second. So now we test, and for easier answer here, I'm going to change this to less. Whoops, did not want to do that. I'm going to change this to less than or equal. I don't know why my computer is doing this. Less than or equal. So I am going to shade 0 less than or equal to 200. That's true. So now I'm going to shade underneath, which will at least help, because at least I will be in a more easily graphable region. Above would have been too much of a pain. All right. Now, y greater than or equal to 10. It's going to be a horizontal line at 10. So I'm going to go 2, 4, 6, 8, 10 and put a horizontal line here. And again, I'm shading this. So right now there's my overlap area, like so. And for a better graph here, I'm going to actually do less than or equal. So I'm shading left of 20. So 20 is right here. I wanted to change colors. 20 is right here. And if I go left, it's going to look like this. All right. So now I'm looking for my region that is all three colors. I'm going to change the view so it's a little bit easier without all the up and down. Okay. So I want above the green line, left of the blue line, and under the red line. Like so. So that's my region. All right. And now the corner points are going to be right here, right here, right here, it looks like, and right there. So remember, that was 0, 40, 2, 4, 6, 8, 10. This was 0, 10. This was 20, 10. And 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. 20, 30. Those are my corner points of the area, the overlap area. All right, much easier one here. Y is less than X. Okay, so that's the line Y equals X. That is going from here like so. All right. Now, the problem is here, we cannot use 0, 0 because it goes through the origin. So just pick a point that's easy. I'm going to pick out here 10, 0. So is 0 less than 10? Yes, it is. That is a true statement, which means I need to shade this side of that line. X is greater than or equal to 4. X is a vertical line at 1, 2, 3, 4, which means I'm shading this way. So my overarching region is going to be this, but technically it's actually going on forever this way underneath it, but on this graph, that's the region. I'm not doing corner points, just graphing right here. All right. On this one, I'm going to solve by cover-up method on the first one. So x is -2. So that would be right here. Oops, sorry. I'm not coloring it, I'm just putting dots. X is -2 right there. And y would be -1 right there. All right. And I would normally get more dots, but I'm just kind of doing a general one here. And we test 0 is greater than negative 2. That's a true statement. So we're going to shade above this line right here. Now this one, the second one, does not, cover method doesn't work well. So I'm going to make this 2y is less than, and notice it's less than. So technically I should have done dotted line here. Sorry, my bad. Did I miss this in the last one? Yeah, this one should have been a dotted line also. We won't usually have dotted lines in our real world problems though. So 2y less than negative 5x plus 6 divided by 2 less than negative 5 halves x plus 3. So my y-intercept on this one is 3. 1, 2, 3. And my slope is down 5, right 2. Up 5, right 2. And it's going to look approximately like this. This is a very tiny graph. So dotted line again. And we're going to test 0, 0. So 0 is less than 6 is a true statement. So I'm going to shade this way. So my overarching region is kind of like this triangle area right here. Again, it would go on forever and ever like so. All right. Just reviewing some graphing. And this last one, again, cover-up method will not work well on the first one. So I'm going to get 3y is less than negative 2x minus 3, and then divide by 3. Y is less than, start to put equals, less than negative 2/3 x minus 1. So minus 1 is my y-intercept. I'm going to go down 2, right 3, up 2, left 3. And I'm going to really roughly sketch this. Again, it should be dotted. All right. I can test 0, 0 because it goes below it slightly. So 0 is less than negative 3. That is a false statement. 0 is not less than negative 3. 0 is greater than every positive number. So I'm going to shade below this line. I'm going to do the cover-up method on this one. So my y is negative 4. Right there. Move this over. My x is negative 6. And again, now this one is a solid line. And 0 is greater than negative 12 is a true statement. So I'm going to shade like so. And my region of overlap is this right here. Because these are actually parallel lines. So the area in between them is my answer.